Today we're going to talk about dividing decimals, and we're going to focus on dividing decimals by decimals. So to do this, we're going to actually slide, raise the roof. So first, let's talk about the different parts of a division problem. So the thing being divided, that's inside the division house, that is the dividend. And the outside part is the divisor. That's what we're dividing by. What is the answer to a division problem called? That is called the quotient. Now, you have learned in the past to divide. If there's a decimal in the dividend, you just bring the decimal up and then divide regularly. So you can have a decimal point in the dividend, but you cannot have a decimal point in the divisor. So in this part, there cannot be a decimal point. So we need to get it out. So the way we're going to do that is really by multiplying by a power of 10. So what does that mean? We're going to slide, raise the roof. The first thing we're going to do is slide the decimal to make the divisor a whole number. Then we're going to take the decimal point in the dividend and slide the decimal in the dividend the same number of places. And then we're just going to raise the roof, which means raise the decimal in the dividend to the quotient. So what on earth does that mean? So let's say that we have the problem 3 45/100 divided by 5/100. Notice I can write it just like this as a fraction. And top dog goes in the house, so this is how I write it as a decimal. Technically, what are we doing? Technically, we want to multiply by a power of 10 to get rid of the decimal in the divisor. So this says 3 45/100 divided by 5/10. I don't want 5/10. I want a whole number. But before I do that, let's actually just do the division problem as 3 45/100 divided by 5/10, but we're going to use a calculator to do this. So 3 45/100 divided by 5/10, so I'm going to do 3. So I'm going to do 3 45/100 divided by 5/10. And I get 6 9/10. Okay, so that is 6 9/10. However, when we do long division, we can't do that. So we're going to slide, raise the roof. I need to make the divisor a whole number. So right now it's 5/10. So I want to make it 5 wholes. So how many times would I be moving the decimal point? 1 time. So I'd move this 1 time to make it 5. But if I do that, I have to do the same thing in the dividend. So I need to move that 1 time. So now I'm going to have 34 5/10. And then I raise the roof. I bring the decimal straight up. So now my new division problem is 34 5/10 divided by 5. Technically, what did I do? What I did is I multiplied by 10 on both the numerator and denominator, meaning both the divisor and dividend. So is that the same thing? Well, let's look at this. I am going to now do my new problem. My new problem is now 34 5/10. So let me clear that. 34 5/10 divided by 5. What do I get? 6 9/10. So my answer is going to be the exact same thing. They are equivalent expressions. All right, let's just do some practice. So right here, I'm going to look at this problem. It says 234 divided by 1 2/10. Okay, 234, that's fine. That's right here. And I'm going to divide by 1 2/10. Oh, no! Can we have a decimal in the dividend on the outside? The answer is no. So I can have it in the divisor, but not the dividend. So I need to get rid of it. So since it says 1 2/10, I need to make that a whole number. So how many times do I need to slide it? 1 time. So that way it makes 12. So I slide, slide, raise the roof. So that becomes 12. So I got to slide it in the dividend as well. But do you see a decimal? There's an invisible one right here. So I need to slide that the same number of times, which was how many? 1. So I'm going to have to slide it 1 time, but I have to put something in that spot. So I'm going to put a 0. So my new problem is now going to be 2,340 divided by 12. Is it the same thing? Well, let's check. So first I'm going to do 234 divided by 1 and 2/10. So 234 divided by 1 and 2/10. Let's try that again, 1 and 2/10. And I get 195. So that's 195. So is 2,340 divided by 12 the same thing? So let's look. Okay, I'm going to clear this, maybe. Okay, so I'm going to do 2,340 divided by 12. And voila, 195. So they are equivalent expressions. I'm going to get the same answer. It's just that we can't mathematically, with long division, divide it with a decimal in the divisor. So we have to make an equivalent expression so that we can do it. So let's look at another one. The next problem that we're going to talk about is 1 and 525 thousandths divided by 25 hundredths. So in this problem, how many places after the decimal point are there in the divisor? There are 2 places. So I need to make that 25 hundredths into 25 wholes. So I need that to be 25. So to do that, I'm going to move the decimal point how many times? 2 places. If I do that there, I got to do the same thing in the dividend. So I slide, slide, raise the roof. So I got to slide here. 1, 2. So it's going to be right there in between that 2 and 5. And I raise the roof, bring it straight up. So that's now going to be 152 and 5/10. And again, I bring that decimal straight up in the new place, not in the old place, but in the new place. So is that the same thing? Well, let's look. So I'm going to do 1 and 525 thousandths. Maybe. Okay. Divided by, whoop, that's definitely the multiplication symbol. Divided by 25 hundredths. This is easier said than done. Okay, and that equals 6 and 1/10. Whew, finally did it. So 6 and 1/10. Is that the same thing when I make the new problem? So I am going to do 152. So let's see this. 152. It's way easier said than done. And 5/10 divided by 25. And I get, voila, 6 and 1/10. So they are equivalent expressions. So now what I want us to do is look at these next 2 and turn them into new problems. I'm not even going to have us figure out the answer. I don't care about the answer. I just want to make equivalent expressions that we could solve if we were going to. Don't worry, I'm not going to make you divide by 3.12 in real life. So this first problem says 18 and 96 thousandths divided by 3 and 12 hundredths. Go for it. Have fun. Just kidding. Okay, so I can't have a decimal in this part. I can here. This is fine, but not here. But if I move the decimal point here, I got to do it here. So how many times would I need to move the decimal point to make the 3 and 12 hundredths a whole number? I need it to be 312. So that means I need to move it 2 places. So that means I got to move it here 2 places. And then I raise the roof. So that now is 1, 8, 9.6. And I raise the roof to the new place. Don't solve it and then go back and put the decimal in the original place. This is the new place. Okay, what about this next one? 4 57/100 divided by 2/10. Okay, how many times will I move it so that there's no decimal in the divisor? One time. That way it's just 2. So if I move that once, I have to move it here once. So that makes that 45 7/10. And then I raise the roof. I bring it up right there in the new spot. Those are equivalent expressions, same problem, but now we could actually work it out. Okay, I'm going to have us just do some practice problems. The first one we're going to do is 37 2/10 divided by 15. Okay, that written like with the division sign is 37 2/10 divided by 15. If I put it, top dog goes in the house, that's 37 2/10 divided by 15. Is there a decimal in the divisor? No, there's none in the divisor. There's one in the dividend, but that's okay. We can have one in this section. So we're just going to bring that decimal straight up. We just raise the roof. We don't have to slide anything. Now, when we're dividing, I like to make a tic-tac-toe chart, or as y'all youngins call it, a hashtag, or I don't even know. So multiples of 15, you think of a clock. We have 15, 30, 45, 60. Those are the 4 sections of your clock. 75, 90, 105, 120, 135. That helps us when we're dividing. So I'm looking at 15 does not go into 3. So I put a 0 there. It is so important to make sure you have 1 digit above every digit. This is where you've got to be really careful that you're lining up. That's why I've got this on graph paper. So now I'm going to look at 15 into 37. So what's the closest I can get to 37 without going over? 30, which is multiplying by 1, 2. So I'm going to put the 30 right here and the 2 right here. I subtract and I get 7. So I bring down that 2. What's the closest I can get to 72 without going over? 60, which is multiplying by 1, 2, 3, 4. So I'm going to put the 4 right here and the 60 here. And I subtract and I get 12. So now I'm going to add a 0 in the dividend, not in the quotient. I don't put it in the answer, but in the dividend, and I bring it down. And I have 120. What's the closest you can get to 120 without going over? 120, which is multiplying by 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put the 8 there. So I am done. So my answer is 2 48/100. What is the answer to the division problem called? The quotient. That is a quotient. Yes, you need to know that vocabulary. So now let's do another problem. This time we are going to do 6 12/100 divided by 5/100. So top dog goes in the house, meaning the number on the top goes on the inside. So I have 6 12/100 divided by 5/100. I cannot have a decimal in the divisor, so I need to slide, raise the roof. I need to slide this 2 times to make it 5, right? So that to be a 5. If I slide that 2 times, I got to do the same thing in the divisor. So 1, 2, and I raise the roof. So that now is 612. And again, I bring that decimal straight up. I'm going to do the same thing and make that little tic-tac-toe chart. And I'm going to use my multiples of 5. You don't have to do this. It's just a good strategy if you need help with your division. Because that, if you do this, 9 is as far as you should have to go. So I'm looking right here at 6. What's the closest I can get to 6 without going over? 5, which is multiplying it by 1. So 1 and then 5. Subtract, I get 1. Bring down my 1. Now I've got 11. What's the closest I can get to 11 without going over? 10, which is multiplying it by 1, 2. So I'm going to put my 2 and my 10. Subtract, I get 1. Bring down my 2. What's the closest I get to 12 without going over? 10, which is multiplying it by 2. Notice, side note, that there is 1 digit above every digit. That is important. Okay, I subtract, I get 2. I'm not done. Do I just say, oh, it's 2 repeating? No, I have not had anything repeating as I've been doing this yet. I'm going to add a 0 and bring it down. So now I have 20. What's the closest I get to 20 without going over? 20, which is multiplying it by 1, 2, 3, 4. So there's my quotient. My answer is 122 and 4/10. Okay, let's try another one. Okay, how is this read? It's 0.1152 divided by 0.12 or 1200ths. I can't have a decimal in the divisor, so I'm going to have to slide, raise the roof. So this slides twice to become 12. So that means this has to slide twice. And I raise the roof in the new spot. So with my new problem, I don't need to write this 0 right here because that doesn't have any value. Either does that one. So my new problem is going to be 11 and 5200ths divided by 12. And again, bring the decimal up in the new place. Notice I keep stressing that because that's the mistake people keep making. They try to go back and put it back where it originally was. I'm going to go ahead and just make my multiples at 12. Knowing your multiplication facts makes life a lot easier. Okay, does 12 go into 1? 0 times. It can't go into 11, so I put a 0. So now I'm looking at 115. What's the closest you can get to 115 without going over? 108, which is multiplying it by 3, 6, 9. So I'm going to put a 9, which is 108. I subtract and I get 7. I bring down my 2. What's the closest we can get to 72 without going over? 72, which is multiplying it by 3, 6. So and a remainder of 0, so I am done. So my answer is 9600ths. Okay, we're going to do one more problem. I'm writing it this way. 18 and 8800ths divided by 1 and 6/10. How would I write that with the division house? Okay, top dog goes in the house. So really this is on the outside. I can't have a decimal in the divisor, so I gotta move it once. So I move it, slide here once, and raise the roof. So my new problem is gonna look like this. Now, when you're looking for your multiples of 16, and I didn't know this until like way later, Your multiples of 16 would be every other multiple of 8. Now, I don't expect you to know all of those, but I know at least some of them. Like if I think about it, like 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, then 96. So that's enough to get me like started. So I would just, it's every other one. So I'm going to put these in here. No, I don't expect you to know after that. So after that, you could add 16, or you could say, oh, 16 times 7. I'm going to give you a hint. It's 112, then 128, and then 144. No, I don't have those memorized. I just have where I've done it previously right in front of me. So I am going to come over here. Again, make sure you have one digit over every digit. So 16 cannot go into 1, so I'm going to put a 0. I could go 0, subtract 1, and then bring down the 8, but there's no point of that. So I'm just going to move right on. 18, the closest I can get to 18 without going over is 16, which is multiplying by 1. Subtract, and I get 2. Bring down my 8. The closest I get to 28 without going over, 1, which is 16. Subtract, and I get 12. So bring down my 8. And the closest I can get to 128 without going over is 128, which is multiplying by 1, 2, 3, 4, 5, 6, 7, 8. And I'm done. So my answer, or my quotient, is 11 8/10. I hope this fabulous, very entertaining video was helpful.